Hello, and welcome to our video on section 2.4, Compound Inequalities. So compound inequality is simply when we put two or more inequalities together and we separate them with the word and or with the word or. We learned about the importance of those words in Unit 1, and if you recall, and corresponds to an intersection. And for an intersection, we used the symbol that looked like an N. And then for an or statement, it should correspond to a union. And again, that symbol looked like a capital letter U. Oftentimes, you will also hear an and referred to as a conjunction and an or statement referred to as a disjunction. So let's look at our first example. Example 1 has an and between the two inequalities. You are simply going to solve each inequality separately, and then we're going to look at how the intersection would be because we're using the word and. So I'm going to divide both sides by 2 here. 2x is less than 8 to get x is less than 4. That's my first inequality. My second inequality, I'm going to subtract 1 from both sides to get x is greater than 2. Now I'm going to put my solution on the number line and see what I get when I graph that. So I'm going to again have x is greater than 2. And in a different color, I'm going to use a light blue. X is less than 4. And notice I put here that that's my work because what I want to see is where is the intersection, the overlap. So what I'm actually going to put on my answer is going to be all of the numbers from 2 to 4 because that's where the intersection is. Now if you notice in part B, the question is asked, what if we were using or for that same inequality? Well, if I look at my work, do you notice that if I take the dark blue and the light blue, I've actually covered everything on the graph. So my answer would be all real numbers because I would have graphed everything. All right, so let's see how those two answers are going to look with interval notation and set builder. First, we'll do our and solution, and in interval notation, that's going to go from 2 to 4, but not including 2 and 4. If we write set builder, we're going to say x such that x is greater than 2 and less than 4. So remember, you always want to go from small to large when you're using set builder and the inequality. In the interval notation, because it's all real numbers, I'm going from negative infinity to positive infinity. And in set builder, we would just say x such that x is a member of the reals. All right, let's move on to example 2 so we can look at an or compound inequality. So in this one, again, the first thing I'm going to do is I'm going to solve. So I'm just going to move that number line down a little bit for myself here. And then I'm going to solve each inequality. And the first one, I'm just going to subtract 1 from both sides. So notice the way I solve is exactly how I would be solving if I just had that inequality by itself. And then on the second inequality, I have to remember all of my rules for inequalities. Because I'm dividing by a negative, I reverse the inequality and I get x is less than 3. So now I'm going to, again, graph this, and this time I'm going to do some color coordinating to help us differentiate. So I'm going to start with the x is less than 3, and then to the right of that will be 5, and I'm going to use a closed circle here because it's greater than or equal to. So notice here that's going to be my solutions. Ors generally go away from each other and are generally a bigger answer set. So we're going to go for our interval notation. Now notice we have 2 intervals here. So I'm going to again color match those to make sure we're clear. Negative infinity to 3. And then I'm going to use my union symbol in between, and then we'll go from 5 to infinity. So hopefully that makes sense for interval notation. When we use our set builder notation, we're just going to use an or in between the two inequalities. So x such that x is, again, we could start with either one, but I'm going to go from small to big. So x is less than 3 or x is greater than or equal to 5. So again, that's going to match what we solved for up above. Now, if you look at this graph that we did for part C, and you think, okay, that is based on an or statement. So we're looking at the union of those two pieces of the compound inequality. But what if we were asked to answer the same question and there was an and in between? Do you see an overlap on that graph? There is no overlap, and therefore the solution is either, again, we can write it this way with empty brackets, or you can write it with this. The number line is a visual representation of your answer, so it should be left blank. All right, let's go on to example E. And in here, what I want you to see is that even though we don't see the word and, it's implied in the question. So we would read this, 3 minus 5x is greater than or equal to -2 and less than 13. You could separate that into two inequalities, but I want to show you how to solve it simultaneously. What you have to remember is what you do to isolate the variable, you're going to do to 3 parts. So my first step is to subtract 3 to get the -5x by itself, but I have to do that for all 3 parts of the inequality. So that's going to give me -5, and in the middle I have -5x, and then 13 minus 3 is 10. So now I'm going to continue the process, and I'm going to divide both sides, excuse me, not both sides, all 3 sides by -5. And the same rules apply. That means I have to reverse my inequality. So -5 divided by -5 is +1. I'm reversing my inequality to get x, and then reverse my inequality. 10 divided by -5 is -2. Now, I usually go from the smallest, again, it's pointing to -2, x is greater than that, and then 1. So if you write your answers going from smallest to largest, then when you graph, you're always, you've got the numbers in the right order. So again, I can put the open circle on -2, the closed circle on 1, and it's going to be everything in between. All right, so that is how we would write, again, our graph. Now we want to go ahead and write an interval notation. So in interval notation, we would write that from -2 with a parentheses because it's not included to 1 with a bracket. And then in set builder, we would say x such that, and we can just repeat the inequality that we used from above. Now, if you wanted to, you could write the answer with the word and. We could write x is greater than -2 and x is less than or equal to 1. But we would need to have the word and included. All right, moving on to our last example, F and G as a partner to that. We're going to, again, solve each inequality separately. So I'm going to here subtract 3 and get -4x is greater than 4. It's a little messy. Let me clean that up. And then I'm going to divide both sides by -4, which means I'm reversing my inequality just as I would any other. And I get x is less than -1. In a similar way, I'm going to solve the next inequality and get 4x is less than 4. When I divide by 4, I'm going to get x is less than +1. So notice here I included a work graph. So I am going to show, let's see, I'm just going to add a different color here so we can differentiate these on the graph. So in blue, I'm going to put x is less than -1. And then in my light purple color here, I'm going to put x is less than 1. Now remember, we were solving with an or. So because it's an or, we want to be more inclusive. It can be less than 1 or less than -1. And therefore, our final answer that we're going to graph is going to be x is less than 1. So remember, the union, or the word or, means it can be one or the other, so it's generally a bigger answer. In my interval notation, I'm going from -infinity to 1. And in my set builder notation, I'm saying x, where x is less than -1. We're going to look at the same problem, but we're going to ask what would happen if we would instead answer for the word and. Notice here, if we go back and look at our work, in that work, we want to look at the overlap. And the overlap between the light purple and the dark blue would be where we see x is less than -1. So my answer over here, if I change the word to and, would actually be x is less than -1. And so I would write that, again, from -infinity to -1 with parentheses, and then x such that x is less than -1. And I just spotted a mistake. You probably did too. But I wrote over here, when I did my or statement, I wrote the set builder with a -1. So I'm going to correct that right now. Hopefully that will help you with the problem set. And if you have any questions, please bring them to class.